Good morning to all of you. Please feel free to scan the QR code and do the event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link and the QR code again with the event ID in the Q&A section shortly. Thank you all again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. I would now like to welcome Nilesh, our speaker for today's session. He's a data architect with 18 years of industry experience in finance, retail, and healthcare domain. Well, when he is not thinking or talking about technology, he likes watching cricket. But for now, I will hand over to Nilesh to begin the session. Over to you, Nilesh.
Hi, Rashmita. Thank you. Thanks for the introduction. I'll start sharing my screen. Let me know once you're able to see it.
Yes, Nilesh, we can see your deck.
Okay. Fine, let's get started. So my name is Nilesh Gule, and today we'll be talking about monitoring Kubernetes with Prometheus and Grafana. Before I start, let me give you a quick introduction about myself. Who am I? So as Rashmita said, I have a Microsoft MVP with about 4 years of MVP recognition for last 4 years. I started off my career back in 2003 in Bangalore, and Bangalore holds a very special place for me. That's where my IT journey started. I was in Bangalore until 2010 before I moved to Singapore. So I put here some of the social media handles in case any of you would like to connect with me after the event. Feel free to connect. Just mention that you were part of the event so that it's easier for me to understand why you're trying to connect with me. I'm also co-organizer of the Azure Singapore user group, and we have been conducting similar to the Reactor quite a few sessions as part of our user group. And if you are interested, you can look at the meetup, and you can also subscribe to our meetup channel. I was born and brought up in Goa. I did my schooling, everything in Goa. So if you are aware that Goa is quite beautiful. If you've not been there, you might have probably seen some of the Bollywood movies which try to show Goa in very picturesque landscapes. And I miss it quite a lot being away from Goa. So with this background, let's come to today's session and what we'll be covering during today's session. We'll start with understanding why do we need something like Prometheus and Grafana. We will look at what is the architecture of Prometheus, and then we will look at two different kinds of project, one coming from Spring Boot, and we'll see how to integrate a Spring Boot application with Prometheus and Grafana. And then we will move on to a .NET Core and see how to integrate a .NET Core application with Prometheus and Grafana. And hopefully, if time permits, we will also look at the last section, which is to enable alerts and to see if we can fire some alerts if something goes wrong in our setup. So some prerequisites for this session. This session is supposed to be slightly intermediate or advanced level. And since we are talking about containers, Kubernetes and all, I expect you to understand or have basic knowledge about these things. Like what is Docker, what is Kubernetes. I put some bullet points here about these technologies. Also understanding of things like what is the container registry, and I'll be using Azure Kubernetes Service, which is the managed offering from Microsoft Azure. So a bit of understanding of AKS as well, if you know about AKS. This is, I would say, from what I'll be using as part of the demo, but AKS is not really a prerequisite. Any Kubernetes environment would do. So let's start with understanding why do we need something like Prometheus, Grafana, or why these tools are becoming popular. Before we go to Prometheus, in some perspective in terms of what is happening with regards to cloud and cloud native adoption as such. if you look at this summary, there was a survey conducted where the people who responded to the survey, they said that 65% of the companies right now, they are using cloud, and 18% they plan to use cloud in near future, which means that almost close to more than 80% of the companies are already on cloud, or they are planning to use cloud technologies. 25% of the developers, they are already on Docker, and 75% this has accelerated their workflow and development. And we know that things like CI/CD, they really help us in improving the overall workflow, as well as getting agility into our deployment cycles and making releases faster. Also, there are 4 million developers who have already switched to cloud native development, and in about next 1 year, there are 7 million more who are planning to move on. So what this tells us is that there is quite a substantial shift in the amount of workloads that are moving to cloud, and those organizations or those companies, as well as those people who are not adopting cloud native technologies, they will be left behind. And one thing which is to understand quite clearly as well is some of the services nowadays, they are available only on cloud. You might not find them at all in the on-premise kind of setup. So this forces many of the organizations who don't want to move to cloud to be like left out. And that's another reason why cloud native technologies and cloud in general is becoming quite popular, and the adoption is increasing day by day. So when it comes to the Prometheus and Grafana, how does this relate to the overall cloud scenario? So before I move on to Prometheus and Grafana, I would again like to bring in infographics from the CNCF, which is the Cloud Native Computing Foundation, which gives a set of tools and guidelines in terms of how the cloud native space should drive the future of applications and design. So if you look at the different matrix or the different dimensions on which CNCF Cloud Trail works, they propose you some of the common tools or some of the projects which are open source project and which you can use in your cloud native setup. If you are starting an application or if you are migrating an application to a cloud native sort of architecture, these are some of the recommended tools and projects to be used, which Cloud Native Foundation recommends. And especially in the observability area, if you look at number 4, Prometheus is the one which is recommended. And Prometheus was the second project which was adopted by the CNCF after Kubernetes. So you can see that it is very prominent in the CNCF space, and it is used by many companies. So why does companies prefer to use Prometheus? So let's look at the architecture of Prometheus to start with. There are some key components in the Prometheus setup. First one is the Prometheus server itself, which works with things like a time series database and a HTTP server. Those are the internal components of Prometheus server. Then there is something called as the push gateway. We will talk about push gateway towards the end of this session. There is a component called Alert Manager, which is used to alert, and it integrates or it fetches its alert settings from the Prometheus server. And there is the Prometheus Web UI. And there is a query language, which is called as PromQL or Prometheus Query Language. The way Prometheus works is it pulls the metrics. Unlike many other tools or many other similar competitors who are competing in the observability space with Prometheus, they try to push the information, whereas the way Prometheus is designed is it tries to pull the metrics and it needs a HTTP endpoint to pull the metrics. It does the pull on its side rather than push from the application or the consumer side. And the way it works is it uses jobs or exporters, and there is something called as the targets. So targets are basically the endpoints that Prometheus looks at to pull the metrics. And applications which want to integrate with Prometheus, they usually expose a matrix endpoint or something similar where the metrics which are understood by Prometheus, they are exposed. So the reason why Prometheus is popular because it was started with cloud native in mind. It was built from scratch by the company which started Prometheus, they were targeting mainly the container kind of workloads or containerized workloads, and they started with container first approach. If you look at today's architecture of the applications, we are moving more and more away from a fixed set of resources to dynamic resources. We have auto scaling enabled, where based on the load, we might provision additional servers, and when the load decreases, we might keep a minimum amount of resources to reduce the cost of our applications. We also have applications which are running as serverless, like functions, which are triggered only when an event happens. So if you're deploying, let's say, Azure function, we don't even know where that function is running, who is hosting that function. And it just runs because of the way the whole serverless architecture works. Same way, when it comes to Kubernetes, for example, we can define a horizontal pod scaling where the load increases, let's say, on the application. Kubernetes itself can increase the number of replicas of the application, and it can go down. So the traditional ways in which we used to monitor the applications or even the infrastructure, they are not suited for the cloud native kind of workloads where things are changing dynamically and they're changing at a very rapid pace. And that is where Prometheus really shines, because it is able to cater to these kind of requirements where your applications, they are coming up dynamically, and when the load is not there, they get shut down. Even the nodes, they can come up dynamically, and Prometheus will be able to extract the required metrics when the application is running, and it will store it inside its own database. And then we can run the UI, which is provided by Grafana, to visualize those metrics. So let's look at the different types of metrics which are provided by Prometheus. The first one is counter, which is a basic cumulative metrics. It's a monotonically increasing counter, which means that it can have only positive values. This is used for something like request, HTTP request, for example. You cannot have negative request coming into your application. You will either have no request, zero request, or every new request will keep on adding to the count. The second one is gauge, which is like a range. So this is mainly used when we have monitoring to be done for things like CPU or any resource for that matter, like the disk space or the RAM usage, which can go up and down over a period of time. So in that case, we will use gauge. Histogram, this is used when we want to observe some sample and count some data regarding those sample of records over a configurable buckets. And this is used for aggregated values instead of counting individual records or individual values. And summary is similar to histogram, but this slides over a period of time. So we will want to have a look at, let's say, what happened during last 1 hour, last 15 minutes, or last 1 day. In that kind of scenario, we can use the summary matrix. So let's see, how do we install Prometheus? What I'm going to talk from here on is about installing Prometheus or working with Prometheus on a Kubernetes cluster. So all the information that I'm providing is related to Kubernetes from now on. You can install Prometheus on regular VM or other workloads as well, but we'll focus this discussion for Kubernetes related deployment. So if you work with Kubernetes before, you know that you can deploy applications on Kubernetes using YAML files, which are called as Kubernetes manifest. That is one way in which you can deploy Prometheus. But Prometheus, as we saw in the architecture, it has got multiple components like the Prometheus server. There is alert manager. There is Grafana required for dashboarding. So instead of building all this by hand, the YAML files, we can use the package manager for Kubernetes, which is Helm. And there is a Helm chart provided by what is called as the Prometheus stack or Kube stack. These people, they combine all these different tools and they package them together as one single YAML file, or not the YAML file, as one single chart, Helm chart. And it makes it easy for deploying the whole stack that is required for setting up the Prometheus. And internally, it also uses the Prometheus Operator. Prometheus Operator is used to simplify and automate the configuration of the whole Prometheus stack. This again is a good practice or a pattern which is used with Kubernetes applications. Think of the Prometheus operator or Kubernetes operator for that matter as a person similar to a person. Like if a person is operating the platform, what are the things he will do? Like in terms of setting up the environment, then managing the versions, persistence, retention policies, replicas, all these kind of things will need to be set up by an operator when the Prometheus cluster or Prometheus environment is set up. And that is done in terms of automation by using this Prometheus operator. So we can think of Prometheus operator as a default settings kind of thing, which comes with all the best practices or highly available settings applied with all the pre-configured settings. So I've used this to install Prometheus on my AKS cluster, which I'll be using. So let me switch back to the demo for a few minutes or some time and show you how to install the Prometheus. So I add the Helm repo, which is from Prometheus community. And then I trigger this command to upgrade or install Prometheus. And I'm setting some values for the Prometheus. So let me open that Prometheus values file. This is provided as an override to the default values, which are used by that particular Helm chart. So I'm enabling something called as service monitor, which we'll see shortly. And then when it comes to the kube controller manager, because I'm using the managed Azure Kubernetes service here, I don't want to measure the metrics for the API server or the controller in this case, the one which is related to the kube controller. So I'm setting some things which are enabled by default to false here, because I don't want to manage or I don't want to see these metrics which are managed by the Azure Kubernetes service. So the kube scheduler, for example, the kube etcd and kube proxy on the master nodes, I am disabling them. I don't want to see the metrics for them. I want to see the metrics only for the worker nodes, which are part of my cluster. So with this override, then I pass those values and I also create a namespace called monitoring, where it will install the Prometheus. So I've gone ahead and already installed this in the interest of time. We can go and see what are the resources that this particular installation provides or installs on our cluster. So we can say kubectl get all the resources from the namespace monitoring. So you can see here that there are about 6 or 7 different pods which are created. One related to the alert manager. There is one for Grafana. There is the Prometheus Operator, Kube State Matrix, the Kube Prometheus itself, the operator, and there are 3 pods which are running as the node exporter. So this will be used for exporting the Kubernetes level matrix, and these pods will extract those metrics and pass it on to the Prometheus server. Then in terms of the Kubernetes services which are exposed, we have a service for alert manager. There is a service exposed for Grafana, the alert manager, operator, Prometheus, and the node exporter as well. We also have daemon sets, and if our cluster scales, let's say currently I have 3 nodes, I add 2 more nodes, then we will also see that this particular operator will be adding 2 more daemon sets here, because we need to extract those metrics from the additional nodes as well. So that is all handled internally by that Prometheus operator for us. And similarly, we have the deployment, we have the replica set and the stateful set. So the data which is there, the database which is used internally by Prometheus, it's stored in this stateful set, or it's managed using this stateful set, and it's stored externally in the persistent volume. So these are the objects which are created after the installation of Prometheus on the cluster, and the operator takes care of installing all this or managing all these resources for me. Now, once I have Prometheus installed, let's look at our first application, which we will be using to integrate with Prometheus. I have a Spring Boot application. It's a simple API for managing, let's say, a conference. And you have things like sessions listed down there, the speakers, then what are the different topics. Those kind of information is stored in a SQL Server 2019 server. And both these components, they are deployed on Docker containers. So everything is running inside Kubernetes service. And we already have the Prometheus installation, and Grafana is also there. So the Prometheus is going to extract matrix from the node level information from the underlying Kubernetes cluster, as well as it is going to extract matrix from our application as well. And then we will use Postman to extract this or to hit the API and get the output. So let's see what are the things we need on the application side so that it can publish the matrix to Prometheus. On the Java side of things, if you know how we set up the dependencies and all, there is this POM file where we mention all our libraries or external dependencies we have. So I'm using something called as micrometer here, which gives us a Prometheus capable matrix. So when I integrate micrometer with Spring Boot application, it will extract the matrix from my application and it will export them to a format in which Prometheus can understand. So those 4 different types that we saw, the metrics which are available in Prometheus, this micrometer will convert these Spring Boot related application metrics into those 4 or multiple types of metrics, which is understood by Prometheus. That is the first step. Once we have this dependency in our POM, next thing is how do we expose that metrics? So that is where we have to change or add settings in our application file. So if I go to the source file and in there is a configuration under the main, under resources, we have the application configuration properties. So in here, I have an endpoint. If you work with Spring Boot, you might know about the Actuator Endpoints. So this is things provided again by the Spring framework, which makes integrating production grade services and things onto the Java applications to make it easier. So in these Actuator endpoints, we have an endpoint for Prometheus. So along with things like the info endpoint or the health endpoint, the matrix endpoint, we are adding an endpoint for Prometheus. So we're saying in the exposure, the endpoints which are exposed, please include Prometheus as well. So what this will do is it will make an endpoint available in the name of Prometheus. And specifically for the Prometheus matrix, we are saying enable the matrix and the management endpoint and export this matrix in the Prometheus format. So once we have these 2 settings, one is the POM updated with the micrometer dependency and adding these endpoints exposure here, our application will be able to expose the matrix in the Prometheus format. So let's go and see what kind of matrix are exposed when this application is deployed. I have again already gone ahead and deployed this application onto the cluster. So let me just clear the screen and change the namespace to default namespace where the application is deployed. And let's see what are the different pods deployed here. So we have this conference demo API deployment, which has happened about 5.5 hours back. And the other ones are related to the other application that I'll be using. There is also this DB deployment, which is the SQL Server pod. So we won't go into the details of remaining ones. Let's focus on the conference demo first. So this is the pod which is running. I also have the service. So let me switch to Octant, which gives a better view. So Octant is like a visualizer for the Kubernetes cluster, and you can run Octant as a UI on top of your Kubernetes. So I'm in the default namespace here, and we can see the same pods running. But if I go to the services, and we see what are the services running. So we have a conference demo service running here, which is running on port 8080. So let's go to Postman and see what kind of matrix is available for this particular application. So here I'm in Postman. The service IP, it is exposed on the load balancer. So .76 is the IP address where it is externally available. So you can see here. And I'm using the actuator endpoint first. Let's see what are the different metrics available at the actuator endpoint. So here in the output, you can see the beans health endpoint info, and there is Prometheus as well. So once we have this available, we can drill down into the Prometheus matrix. So if I request the get method on this Prometheus endpoint, you can see that the application is exposing some JVM metrics like JVM, the garbage collection, max data size. This is the value. The application is conference demo. So it uses these labels to identify which is the application. And this again is coming from my configuration. So if I switch back to the app config file or application properties file, you can see that I've specified the application name and the matrix tags is using that application name here. So that is how we can also identify that this matrix is coming from which application. If there are multiple applications running, we would be able to identify using the label of this that this matrix is related to the conference demo application. And then we have HTTP server request coming in, like the counts, the sum, and there are various other matrix. You can see a big list of items which are available or which are published because of that micrometer enabled matrix. Now, once I have this matrix available, how do I link it or how do I see that in the Prometheus? So when the Prometheus operator is installed, it exposes the Prometheus services. And what I have done here is I have set the port forward on those services. So if you want to look at the Prometheus UI, it's exposed on 1990 port, and I've already port forwarded to that. So I can go in my browser, and if I hit localhost 1990, I will be presented with this UI, which allows us to look at different Prometheus metrics. So let's look at one of the metrics which we saw in the Postman. So let's say this one, the garbage collection promoted. That's the name of the matrix total. And so we can see that over a period of time, it is showing this graph. What was the value of that matrix? So between 12:05 and 1, that is the local time here in Singapore for me. This is the value. It is somewhere between 38 MB to 39 MB. I can also use some of the functions which are provided as part of the PromQL. So instead of looking at just a single value or a series of values, because it's a time series database, instead of looking at the time series, I can also look at like the aggregated values. And this way I can make sure that the metrics which are published by application, they are really integrated or they are really available in Prometheus or not. So how does this happen? Now, application was exposing the matrix, but how did it reach the Prometheus? So we can look at this in the service discovery and the targets feature of Prometheus. So this will give us the view of what is that is currently integrated with this Prometheus instance or this Prometheus server. So you can see that there are service monitors, which is one of the object, a custom resource provided by the operator, which is able to export metrics for things like the conference demo. There is also RabbitMQ, which I'll talk a little bit later. And then it's exporting the metrics for the Prometheus Alert Manager, the Kubernetes API server. It's exporting for core DNS, the kube state metrics, the kubelet, node exporters. All these things are currently being exported from the Kubernetes cluster onto that instance of Prometheus. We can also see, so this is just the configuration to say these are the things which needs to be exported. Now we can look at what is called as the targets in Prometheus and find out the state of that. So here it will show us if there are any targets which are unhealthy. So we might have configured a target, but if there is some problem, it will show us in the unhealthy section. Right now, there is nothing unhealthy, and all the targets that we have configured, they are up and running. So we can go back and we can expand one of the targets. This is the same one what I was looking just now, the Actuator and the Prometheus one. We can see that the state is up, and it will give us details about what is the container from where it is pulling the target, what is the endpoint, which instance, like the node in my cluster it is running, and it will have some metadata which is used internally by Prometheus, like the service ID, the job, and things like that. It will also tell us when was the last time this matrix was scraped and how much duration did it take to scrape the matrix. So to link this, again, I need to make some changes in my configuration or the manifest. The first thing is, let me start with the API service. So on the API service, usually you will say, what are the ports which we are exporting or exposing so that we can access the service from outside of the Kubernetes cluster. Rest of the things, they remain the same, like the kind of service, the metadata, the spec for the service, whether it's a node port, load balancer, or cluster IP. In this case, I'm using load balancer. One thing to add is the name to the port, because this gets used in the object which is used by Prometheus. So it is very important that we name our port. Usually, if we skip the name part, it will work in a normal Kubernetes environment. But in case of integrating with Prometheus, we need to name the port so that it can be accessed by Prometheus. And then we also have to label it. We create an object called as a service monitor. This is a custom object which is created specially for the purpose of Prometheus, and its type is service monitor type. This needs to have a label as release Prometheus, because when the Prometheus operator is installed, it puts a label on some of its internal resources, and it will have this label. If this label is missing, then we will not be able to scrape the metric. So it is very important that in the metadata of the service monitor, we have this label which is named exactly as release Prometheus. And in the specification, we say that anything that matches the app conference demo service, you should select that to scrape. And in terms of the namespace, I can give a specific namespace, or I can say any namespace is fine. In this case, I have given any, which means that this particular service that I am trying to scrape, it can reside in any of the namespace. But let's assume that in your organization, your application is deployed into a specific namespace, then you can provide that namespace here. Instead of saying that any namespace, you can restrict it to a very particular namespace. And then endpoint. Endpoint is what Prometheus will scrape. So this is what we looked at in the Postman. If I go back, that is where we were seeing that matrix. If you remember the actuator Prometheus, that is what we are trying to map here. By default, Prometheus looks at /matrix endpoint, but because we are exposing it as part of the actuator matrix and on the Prometheus endpoint, we have to override that and provide this path. And the port is the matrix port that I just explained when we did the configuration here. So this is that matrix port 8080, which needs to map. So based on this metadata, Prometheus is able to pull the matrix for that service. So whatever deployments are running, in this case, there is only one pod running for the service, but assume that the service was having multiple pods. If there were replicas as, let's say, 2 or 3, we will be able to see this in the next demo where I have multiple pods running. But by targeting a service here, any number of pods which are exposed behind that service, Prometheus will be able to scrape those pods. So now we are at a state where we are able to see that the metrics are coming to Prometheus. how do we visualize this? So that is where Grafana comes into the picture. And since Grafana also is deployed as part of the default installation of that Prometheus operator, we can access Grafana on the default port. So if I go back, Grafana is running on port 80. And again, I'm doing a port forwarding. So if I do localhost 80 or just localhost, I will be presented with the Grafana dashboard. So before I go specifically into the application related dashboard, let me show you one or two which are again provided by the operator itself, which helps us to understand the health of the overall Kubernetes cluster. So you can see under the general category here, we have the alert manager overview. There is core DNS, the API server, the compute resources of the cluster. Let's go down and look at one of the Prometheus related one itself. So there is a dashboard provided by Grafana to see different aspects of Prometheus service itself. So you can see here that it's showing the Prometheus stats. What are the instances where this core DNS is running, where the API server is running, which port it's running, what is the uptime for that, how many targets are there, how many targets are syncing currently. So let me pull down. Here you can see that these are the different targets which are being synced right now. So we have something coming from Tech Talks Consumer. There is a conference demo service monitor, RabbitMQ service. So Prometheus is able to scrape a matrix from all these endpoints. And if there are any failures, those would be shown here. The storage is also shown. And these are all the details related to Prometheus. Let's look at maybe one or two other cluster level metrics before we go to the application. So go manage, yeah, discard. Let's look at the cluster level resources. So here we can see that currently only 7% of the CPU is being utilized. In terms of the request, so in Kubernetes, we can define what should be the amount of resources that are utilized by our pods or the workloads. So here we can see that 22% of the requested CPU is being committed. The limits are set to 40% of the available resources, and same way like memory also, we have the statistics there. We can find the CPU usage. We can find the different requests by the namespace. And all this is coming default. I didn't edit anything. So I didn't have to change anything. This was all part of the installation of that operator thing. If I want, I can change the look and feel of this. So you can go to edit and you will see that how is this data coming in. So you are summing up the container memory RSS, that is the metric which is used to provide this dashboard or to provide this widget. And then we are grouping this, or we are summing this by the namespace. So we can change all this information. We can also change the type of the widget used on the right hand side here. The display can change from line into bar, or the width can be changed, and all that customization can be done as per your choice. So you can see here that there are a lot of options which are available. Once the data is linked, once the link is established between Grafana and Prometheus, it's all up to the creativity of us. How do we want to visualize that data? So now let's go back to the application specific metric. So we looked at the matrix which was available in Prometheus. Now I used a dashboard which is provided by Istio for the micrometer related matrix. Again, I didn't have to spend too much time creating this myself. If I go to the Grafana Labs website, there is an option where you can see what are the different dashboards available for public consumption, and you can take that ID of the dashboard and you can import it into your own Grafana instance. So let me quickly show you how to do that. So this is the dashboard that I referred to. So you see this copy ID here. We can copy this ID, and you can also go back to the Grafana homepage. And if you want to look for other dashboards which other companies or people have published, we can see that. So under the dashboard section, we can search for the type of dashboard that we want. And we can filter here. So let's say I want to look for only Spring Boot related ones. Come on. Something is wrong. OK, but you can use this options here to filter, and then you will get this list of available dashboards, and you can take that ID. And then to use it, you can go into the manage section. So and say import. And you give that ID here and say load. That's one way. You can also download the JSON definition of that dashboard, and you can upload it here. And then you can select where is the source of the data, or which is the data source. Grafana is very rich in terms of dashboarding capabilities. So Prometheus is just one type of the data source it supports. You can hook in Grafana over multiple different data sources. So in this case, we are going to use Prometheus. And when I say import, it will import the definition of that dashboard. So I've done this already. That's why if I try it again, I will get the error. So let me go back to the dashboard once again. Spring Boot, the JVM micrometer. And we are looking at the data of conference demo, because right now there is only one Spring Boot application deployed on that cluster. So you can see that there are different panels here. It will give you what is the uptime, the statistics related to input output, the HTTP duration as well, the rate at which we are serving the HTTP request. Then the JVM memory, JVM CPU usage, load threads, all this information is extracted and sourced from Prometheus and shown onto Grafana. So let's try to query this. Let me hit some load on this API, and we hope to see some changes in these metrics. So let me go back to the terminal. And here I'm running a loop, and I will make 2500 requests to get the sessions detail. And same way, let's do it for speakers as well. Let's hit 2000 times to the speakers endpoint. So now both the session and speaker endpoints are being queried continuously. And we see that immediately there is a spike here. So it is able to pull that information within few seconds. So that information regarding the increase in the number of load and the amount of time it's taking to service that is in almost near real time available here in this dashboard. And if we keep watching this, I'm pretty sure within few minutes or within a short duration of time, all these metrics, whichever are impacted because of those two calls that I'm making continuously, they will start showing change in the values. Okay, let it run for a while, and then maybe we can come back after we finish the rest of the discussion. So that is one way in which, using the service monitor object, we monitor the services that are deployed on the cluster, and we link the matrix of those services coming from Prometheus onto Grafana. Now let me move on to the second demo, which is a .NET Core application. So we looked at application which is Spring Boot based and how to integrate Spring Boot and Prometheus. Now let me switch to the Visual Studio Code editor and show how we can integrate this for a .NET Core application. In terms of .NET Core, let me go back to the slides first to see what the application is doing. So this application is called Tech Talks, and it also exposes an API, which is to generate a set of Tech Talks. It's a configurable number. You can say generate 5,000 or 1,000, any number of Tech Talks. This gets pushed into a RabbitMQ, and the RabbitMQ and the publisher both are running in Docker, and there is a consumer which looks at this RabbitMQ. I'm using a framework, or I'm using another project called KEDA here, which is used for event-driven workloads on Kubernetes. So if there is no workload, or if there are no messages in the RabbitMQ, there won't be any consumer running. But the moment there are messages to be processed in the RabbitMQ, this KEDA will automatically scale within a range, and it will create replicas of the consumer, and it will fetch a certain number of messages in one batch, and it will process that. So here the producer is exposed as a service, which we can call using Postman, or we can hit it from any browser. But the consumer is not exposed as a service. The consumer is running as a standalone exe inside the Kubernetes cluster. And we will also try to scrape the metrics from infrastructure component like RabbitMQ, and we will see what is required. So let's first look at how do we integrate the RabbitMQ matrix, not RabbitMQ, sorry, Prometheus matrix part for a .NET Core application. So I'll start with the producer first, which is a web API. So .NET Core web API in this case. In my dependencies, I need to add two dependencies here. One is the Prometheus.NET, and the other one is specifically for ASP.NET Core. Once I have these two, I can go into my startup.cs, and I can use this method app.use HTTP matrix in my configuration, where I say configure the services. So as part of the middleware for my API, I need to enable this HTTP matrix. This comes from the Prometheus library that I added, or the dependency that I added. And for the endpoints, if I want to measure the performance of different endpoints, then I have another matrix here, or another method, which is called endpoints.mapMatrix. Once I add these two, my .NET Core application, the API, will be exposing these metrics in the Prometheus format. Same way for the consumer side, which is a .NET exe, it's not in web part. So in the dependencies, I add just the Prometheus.NET. And then in my program.cs, I need to expose a matrix server. So that is done using create this new matrix server. I'm specifying I want to run it on port 8080, and I start the matrix server. So that way my exe will be exposing the matrix in Prometheus format. So let's go back into our Postman and try to see what .NET matrix are available here. So 175. So let's first verify that that is still the endpoint where our service is exposed, the publisher, or in the octant in services, if I go RabbitMQ producer service, it is available on 210.175 on port 80. So I go here, and if I hit the matrix endpoint. Now, in this case, I did not change the path. So that is where it is using the default matrix endpoint. And if I send this request, we will see that it is publishing, or it is able to get these different metrics in terms of the process threads. Then there is the open handles, HTTP request in progress for the controller, the different types of actions like or the methods. This is a post method here. Also the codes that is written 404. So all this information is being sent in the form of matrix by my .NET Core application. So once that information is available, I do the same thing in terms of the service monitor. So I will not repeat all those things, but let me quickly show you the part related to the producer where the service is declared. So this is the producer service where I've added the port as 80, and in the producer service monitor definition, I'm mapping this or matching this on a RabbitMQ producer HTTP port and the matrix endpoint. That's the path where it is exposed. And interval I'm overriding here. Default interval is 30 seconds, but I'm changing it to 15 seconds in this case. So now if I go back and look at the .NET Matrix, so I have a different dashboard here for the .NET related ones. Okay, let's look at the Prometheus.NET. So we can see the data coming from the duration of the HTTP request. And same way, I have another one, which is for the controller one. So I can look at the controller summary as well. So the number of requests which is served by the controller, those are available here. So let me do just one change here before we move on to the RabbitMQ side of the visualization. Let me trigger that number of requests here. So this particular get call will generate 5,000 messages, and we should be able to see the number of consumers coming up. So let me switch to the Octant UI. And if we go back to the workloads, what you should see is in the number of pods, hopefully there is no pod running for consumer because there was no messages in the RabbitMQ, and we should see the consumers coming up dynamically. Yeah, so you can see some consumers have been added, and progressively this will increase up to 30 consumers. The limit is from 0 to 30. So once the limit reaches 30, there will not be additional consumers added here. So what I want to show you now is how do we configure for the consumer part, which is exe. And for the exe type of objects, which are not exposed as a service, there is a different type of custom resource provided by Prometheus that is called as a pod monitor. Because I don't have a service to access this particular consumer, I still need the matrix to be extracted out of those pods. And in such scenarios where you don't have a service exposed, we can use a pod monitor. And instead of looking at a service, this is looking at the pods. So if I look at the spec, the specification is something similar to the service, and it looks at the matching of the labels again. And my pod needs to have this label RabbitMQ consumer. So if I look at the consumer deployment, you will see in the definition, there will be this RabbitMQ consumer run as the label. So that is what it is trying to match. And then I'm exposing this on sorry, not the producer, consumer. Come on. And then it's looking at the matrix endpoint or the matrix port. So the matrix port is again defined in my consumer deployment as the port. So you can see here matrix port is defined at 8080. So that is how the pod matrix are being extracted, or the link happens between the Prometheus and the pod monitor. So along with the service, now it's also able to extract the pod related matrix. So let's go back to the previous one and we should see some changes in this visualization here. So you can see that this is coming from the pod monitor, all this information. So Prometheus is able to extract the data from not just the services, but the pods as well. Now, while this is running, while those messages are getting consumed, let's look at the infrastructure component of our setup, which is RabbitMQ. So I'm not changing anything in RabbitMQ, or I don't have the control over RabbitMQ installation because it is again deployed as part of the Helm chart provided by RabbitMQ. But I'm still able to use Prometheus to see the different metrics related to RabbitMQ. And you can see here that there are close to 1,000 messages which are in ready state. Out of those 5,000 messages that I pushed, about 2.25 messages are currently acknowledged, and there are some messages which are in the process. So we have 30 consumers which are consuming the messages, and we also see other details like the number of queues, number of nodes, and along with that, we can also see various other details which are very specific to the RabbitMQ here, like the number of messages delivered so far, how many are pending acknowledgement. We can also see the queue information, how many queues are created, and yeah, so you can see here number of queues created. If queues were deleted, I can see all that information in as part of this dashboard. And this again happens by using a service monitor here for RabbitMQ, because RabbitMQ is again exposed as a service in my cluster, and I can use the same process. I can use service monitor, and there is a matrix endpoint provided by RabbitMQ Helm chart. So I'm using that, and every 15 seconds I'm pulling those metrics. And the label which is provided by RabbitMQ Helm chart is this. So I'm trying to match it based on this name, which is RabbitMQ. So far what we saw is it is quite easy, or it is very straightforward to do it for a Spring Boot application. For .NET Core, we might have to do a bit of code changes. And for external service or a third-party component like RabbitMQ also, we can do it using Service Monitor. That is for the part related to matrix collection and visualization. The last part which I would like to show you is the alerting capabilities of Prometheus. So Prometheus uses something called as the Alert Manager. And if I go into Alert Manager UI, we can see right now there is only a default alert throwing, which is called as the watchdog. So this is by default created to make sure that the Prometheus itself is running. And if the Prometheus is not running, then this would come as an alert. Now, how do I configure alert for my application? So let's say I go back to the Spring Boot application for an example, and I want to configure an alert if my API is not running, if there is any problem with the API. So I can define in a declarative way a rule in Prometheus which uses expressions, and I can tell what should happen as an alert. So in the metadata, I can define these metadata again, like release as Prometheus, app as this Prometheus tag, what is the name of my rule. And in the specification, I say that I want to create a rule or an alert if for 1 minute I don't have a conference demo service pod running. So let's assume that this is very critical. And if the pod is not up and running for even 1 minute, I need to alert automatically to the people who are in charge of this particular application. So I define this rule and I apply this rule. So since this is a Kubernetes manifest, I can go and apply this. Let me see if this is already applied on the Kubernetes cluster. So I can go to the octant again, and in my custom resources, I can see which are the objects which are applied. So I don't think this is applied. So let's go and apply this. I'm in the conference API. So let's go one level up. So I have that YAML file here. Let me bring it up. So the conference API alert rule is available here. Let me go and apply that. So kubectl apply -f and okay, there is no change because it was already applied. So the rule is applied. I can verify that the rule exists in Prometheus or not. So if I go in the Prometheus UI again, back here in the status, in rules, we can see that there is a rule for conference demo rule. It's that same definition that I gave. What is the expression? And the state right now is OK. That means this rule is currently applied and it is not firing. It is last time it was evaluated was about 10 seconds ago. So now to trigger that rule, let me go and delete the underlying pod. Okay, kubectl delete API deployment. So this one will go and delete the deployment for that particular service. Now, if we go back to the Prometheus UI, it will change after some time. And we can also go back to the alert manager and see if something happens here. So let's go to the alerts first. And we see that there is only one alert firing at this moment. If I refresh this, I should see one more alert coming up shortly because we have given that 1 minute duration. So it will evaluate it after a minute or so. So let's refresh for a couple more times. And you can see here that it has appeared that it is pending right now. So far, it's saying this particular pod is not there. We don't have this deployment running, and it will start firing within few seconds. So if I go back to the alert manager, we should see the update here as well once it starts firing. Yeah, so you can see that now it's changed to the firing one, and we should get it in here. So you can see it's available in the alert manager as well. So this way we can then create alerts for different services which are critical to our business, and we can use the capability of Prometheus to alert. Alert manager has target things like you can configure the alert to go to a webhook, you can send it to a Slack channel, you can send it to email. There is this kind of information available on the internet, so I will leave that as an exercise for you to try further if you want to explore it. But once the alert is available in Alert Manager, you know that it's capable of alerting in case of any failure. Then it's up to you. How do you want to notify the alert? So let's go back to the presentation now. So we looked at all these things where we were able to pull the information from the underlying Kubernetes service like the node metrics or the AKS related metrics. We also pulled the metrics from our publisher as well as the consumer, and we were also able to pull the metrics from RabbitMQ. So that brings me to the end of this session and the demo. So to summarize, what we looked at is in today's modern day cloud native applications, we need different ways of monitoring because we are no longer using the static way of deploying our applications. Our infrastructure is changing dynamically. We at times also don't have access to the underlying virtual machines when we deploy things to the cloud. So we can't use the legacy methods of monitoring our applications, and we definitely need to look at the cloud native ways of monitoring. That is where Prometheus is one of the most popular tool. It provides us an easy way to integrate with different platforms and metrics. What I showed was for .NET and Java, but Prometheus has what is called as the exporters for various different types of languages and platforms and services. So if you just search for Prometheus exporters, you will get a big list. Last time when I checked, it was quite a huge list. So you can see that it supports these databases. There are hardware related exporters. There are issue trackers which are supported, messaging systems, storage, HTTP, APIs, logging, monitoring systems. So you can export data out of all this, what is supported here. And there are also community provided exporters from these systems into Prometheus. It's quite a versatile tool, and you can really make good use of it. We also looked at the usage of Service Monitor, how to scrape the matrix from Kubernetes services, and also the Pod Monitor, where you are not exposing a service, then you can use the Pod Monitor. And the Grafana capabilities also, we looked how to build quite intuitive dashboards using the data which comes from Prometheus. And lastly, we also looked at the Alert Manager capabilities. When something goes wrong, we can use the Prometheus queries or expressions based on the data available in Prometheus to alert. So with that, I would like to conclude this session with some of the references for your future explorations. You can go to prometheus.io and grafana.com to know more about Prometheus and Grafana. Then if you are interested in deploying the same stack that I showed, it's available on GitHub, the Prometheus stack. I've given the link for Prometheus Operator as well. If you don't want the complete stack, but you just want, let's say, Prometheus, then you can use the operator part. There is a series of YouTube videos created by Hussein Dalai, the guy at the bottom. So I've given a link to that, and there is also Tech World with Nana. She has also done a series of videos with Prometheus and DevOps related topics. And I've also given a link to a very interesting graphical UI, which or graphical, I would say, resource, which tells how Prometheus does the debugging. And if you're facing any issues, how you can debug problems with Prometheus. The source code is available on my GitHub repo. The links are available here. I've also shared these presentations on SlideShare and Speaker Deck, so you can download them from there and you can access it from there. That's all from my side. In case you joined in late, my name is Nilesh. The combination of my first name and last name is quite unique, so you can find me with the same handle almost on every social media site. And I've given a QR code here to my YouTube channel in case you are interested in knowing about some of the things that I discussed here. I also publish these as short videos on my YouTube, so feel free to subscribe to my channel. Thank you. Thanks all for attending this session.
Nilesh, before we end, we have like one question, and Ashish wants to ask few questions. So Ashish, please go ahead, unmute and ask question, please.
Yeah, good morning, Nilesh, and good morning, everybody else. Nilesh, I've been using Prometheus in my production Kubernetes cluster for monitoring our Spark Scala applications. So I have did the setup myself, or the Prometheus installation, everything, and we are even using the external metrics from some other resources like RabbitMQ. So we have this RabbitMQ exporter deployed and other stuff. My question is, see now this new way of Prometheus Operator, I've been using Prometheus Operator using the Prometheus Helm installation. In the earlier Prometheus, so this is like sort of confirmation I want. Earlier Prometheus, I'm not sure, I never used. It used to do scrapping based on annotations as well. But
Yes.
Now my question is, does Prometheus installed via Prometheus? Many times I get confused with this Prometheus Operator installation and the general Prometheus that people say. So does the Prometheus installation support scrapping based on annotations? Yes or no?
No.
Yes, I also read the same thing. So many times you understand the confusion, right?
Repo, right? Let me take you there. It's
Yeah,
clearly
no,
mentioned
perfect.
in the
Yes,
GitHub
it is
repo.
mentioned. It is mentioned. You are right. It is mentioned there. And because many a time people confuse who knows Prometheus from like long back, they say scrapping based on annotations and all. And you still see on internet, if you see some deployments which support Prometheus, they will give some annotations in their deployments and that are not supported by Prometheus Operator. That's fine. And
Yes.
One more thing is this. So we did the push model also. So we have to install a Prometheus gateway, and then that gateway also again we have to use a service monitor or a pod monitor, right? A service monitor is the key for any metrics to be available in the Prometheus. And
Yes.
this service monitor, is it compulsory that it should be deployed in the same namespace where Prometheus is deployed? I know that release Prometheus, which is the name of your Prometheus installation, that label is compulsory.
Yes.
But I think even the service monitor also has to be deployed in the same namespace as where Prometheus is installed.
Required.
No.
So
Okay.
if you look at the service monitor definition that I have, right, you
Mhm.
have the namespace selector as the one of the attribute. So you
Yeah,
can
no,
specify a
this is
specific namespace here. So your namespace where your service is deployed could be different than where the Prometheus is deployed.
yes. No. My question was the service monitor, the resource service monitor has to be created in the same namespace where Prometheus is installed. No.
No, no,
Okay,
no.
so service monitor can be in some X namespace. Prometheus could be installed in some Y namespace, and your service can be installed in some Z namespace.
Yes, yes, that's
Okay,
correct.
okay. Yeah, I think, and also the alerting part. I believe the alerting is much more powerful in the Grafana. So we use the alerting through Grafana, SMTP configuration, everything. So Prometheus alerting. So I see Prometheus as like more like a time series database. More than that, it doesn't really serve too much purpose from the production point. And when Grafana is also, you use Grafana also along with Prometheus. And also the Prometheus time series database, currently if you go by the normal installation, it uses the local container storage. So we tried to, I think the NAS mounting and all, we get into some trouble there. We are still overcoming that, but that should be some problem with our NAS, I believe. So the underlying storage that we are trying to explore. I think that was pretty much from my side. I think it was a good demo actually. Thank
Thank
you,
you.
Nilesh. Thank you so much.
Thanks.
Do we have any more questions, or can we wrap up the session for today? Okay, I'll take it as a no then. Probably we don't have any more questions. So thank you so much, Nilesh, for the session, and thank you all for joining us today. Please feel free to scan the QR code. Let me just share my screen once again with you all. So I'm hoping that everybody can see my screen. So please feel free to scan the QR code and do the event check-in. This will give you access to additional resources and information. Also, please share your feedback about today's session. It will help us choose our topics that better suit our audiences. Do visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.
Thank you. Thanks all. Have a nice day. Bye-bye.